Cool. So this is an update on some experiments that we're doing in Chrome to analyze image entropy of LCP images and potentially exclude them from LCP. So as background, what we're trying to do here, this is addressing an issue that's been open for a while in the GitHub repo about the fact that a lot of times the image that we capture as LCP is not actually contentful. Right, LCP is primarily a user experience metric, and we've always tried to exclude content that exists and is painted and takes up space, but doesn't actually contribute to the content of the page. It's not something that the user sees, understands, needs for the page. Right, so we've traditionally excluded things like, in some cases, like full viewport images, background images that are just solid colors or just gradients. Things like that have always been excluded, but there's a bunch of other things that we're not catching. And we want to try to do better than this. Basically, like, so that we can more accurately capture the user experience of the page and like when did the real content show up for them. Right. This is a timeline that Annie took using web page test and posted a couple months ago, showing an example of what happens on the web now. Right. So this is a news article, and what they're doing here is lazy loading their main content. They're above the fold main content, which is fun, and they're doing this in a way that they're reserving space with a transparent placeholder that's getting flagged in that middle slide as green because it's the LCP, but it's completely transparent and exists only to reserve space for the image that gets loaded, about a second later. So we really feel that second point is what should be marked as the LCP, right? That's the actual content. So how can we do this? The one idea that we've got is to basically look at the entropy of the images, right? So the information density. And there's lots of ways that you can define such a thing, all kinds of information theory around this. But we want to go like as simple as possible. And like the easiest thing we can do is look at bits per pixel. Literally, I'm looking at the number of bits in the resource transfer size. So we're assuming that there is compression built into the image format and that the compression is doing its job and that the image is compressed roughly down to the sort of minimum number of bits that you need to express that image. And for pixels, we're looking at the CSS pixels that are actually used on the page to render this. So this is certainly
Did they get muted?
oh, sorry.
You disappeared. So.
How about now?
Yeah.
Okay, excellent. Did we get bits or just? I'm not sure how far back I should go. Okay, Michael's saying yeah. So pixels is CSS pixels that are used to render the image. So this is sensitive to the device size. Smaller devices have fewer pixels to work with. It is also sensitive to container scaling, so that if you have a small image and you blow it up into a large container, that is more pixels. Conversely, if you have a massive image and you scale it down to a tiny div, right, that's fewer pixels. We're using CSS pixels so that we exclude things like device pixel ratio, and you don't get penalized for using something with like a 2 or a 3 DPR. So about a year ago, I took a look at HTTP Archive and measured the entropy of all of the images on all of the home pages. And this is what we saw, a nice distribution. This is actually a log scale on the bottom of the bits per pixel because this is an incredibly wide variance. We are seeing on the low end things like tens of thousands of pixels per bit. And on the high end, we see thousands of bits used to represent individual pixels. We went and did the same thing in Chrome to actually measure and report back the actual LCP entropy for every page load that users see. And we classified this into nice, sort of logarithmically spaced buckets. And this is what we get. So roughly the same thing. And again, like the left edge of this graph is values of 100,000 plus pixels per bit. And with the right edge being values of like 10,000 plus bits per pixel. The peak value in the middle there is basically between 2 and 3 bits per pixel. which is roughly what we saw in HTTP archive, and it sort of matches what we roughly think as reasonable image encoding. There's about 75% of the samples in this central peak here, between 1 and 20 bits per pixel. Between about 0.6 and 60, we get about 90% of the samples. And those are all content, right? Like, this is not what we're interested in. What we're really interested in is the low end, right? This is where we think that we're going to see blank images and placeholders and 1 pixel images blown up to the entire viewport and all that. So that's what we want to like focus on. So what we did is we took a look at a number of sites whose LCP images ended up in each of these buckets. At the very low end, right, these are all sites whose LCP images was like at most 0.02 bits per pixel. What we saw as the LCP image was this. So more accurately, we saw this. In essentially every case, right, it's a full screen transparent image encoded as a data URL. And this loads really, really quick, but it does nothing for the user. Right, and so in those bottom buckets, like that's literally all we see. As we move up a little bit to about here, we start seeing things like solid color backgrounds or just simple gradient backgrounds. Sometimes smaller placeholders that are still transparent, like we saw in that initial film strip. Maybe not full viewport, but a reasonable size of it. And it's not until we get to about, actually this bar is in the wrong spot, I'm going to move that, but to about 0.2 bits per pixel that we see the first signs of anything that might be content, right? It's still mostly transparent images and solid color backgrounds, but they're getting smaller, right? Like I said, because this is sensitive to viewport size, right? These smaller your transparent images, I guess the more entropy it has. But we also see a couple things that are like simple SVG icons or backgrounds that are used behind text and that kind of thing. That still might be worth filtering out, but it's more debatable. So what we're doing at this point now, we've been experimenting this in Chrome beta, imposing sort of a cutoff for LCP. So at like these 3 different points, this is like 0.01, 0.05, and 0.2 at our high end. We experiment with just throwing out any images that don't hit that threshold and say these are not candidates for LCP. And we will move on to the next largest image that actually meets that bar and report that. And we think that this is going to have a relatively small effect overall on LCP, but it should, for the sites that are using things like this, actually push their LCP forward a little bit to the point where you get the content that the user can actually care about. Unfortunately, this is still on beta, so we don't have real numbers. We're seeing like maybe a % shift in LCP overall, but until we get it to stable and I can actually see, we won't have anything real to report back. And I think that's the end of those slides. I'm happy to take and answer questions on all this.
Let me stop the recording. And